Very good morning to you all. So today I would like to start with your exercise 8.4 question number 5 first part. Now in question number 5 all the parts are very important from the understanding point of view, and I will explain the answer in detail to you with all kinds of options which are possible within the answers. Suppose I am taking the first part here. You see, we need to prove that cosec theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. Now, when we begin with the topic, I said these are the standard identities or the conditional identity. What does it mean? Conditional means if you are going to start with left hand side, you are not allowed to transform from one side to other side. Just in the beginning, that is in the very first step. No changes you can make of your own. If at once you have started with left hand side, so you have to proceed with the left hand side. And if you want to start with the right hand side, so you have to proceed with the right hand side only. So what does it mean? Just in the beginning, before starting writing my answer, I need to take the decision that with which side shall I start writing my answer. So that is very important. For that you need to give a second thought. Like here suppose. So if you ask yourself why I started with left hand side, so most of the time you also will be getting answers from your side. Okay, if this side I will compare with this side I am finding in the most simplified form, that is in term of cos. As I earlier said that the most simplified form are sin theta and cos theta. So that's why I have the option available here. I will go for conversion of cosec as well as cot in terms of cos and sin, and that I do. This is the whole square. Now another option, sometimes students they are immediately shifting to the expansion. Please be careful. These are some out of the box thinkings you need to pay attention here. Do not go for expansion like a square plus b square minus 2ab. Again ask why. Because I don't need anything in square in my right hand side. That's why I need to pay attention. What is there in the left hand side and what do I need in the right hand side? I don't want any square, so I will avoid that expansion in terms of a square plus b square minus 2ab. That's why I avoided that, and I have written cosec is the reciprocal of sin, and cot can be expressed as cos upon sin and whole square. Now what I did, I have taken the LCM here, sin theta, and on that we have, I will be getting the numerator is 1 minus cos theta whole square. So now I have, this is the numerator and this is the denominator in terms of whole square. So 1 minus cos theta whole square, because I am watching simultaneously to my right hand side. I need this 1 minus cos theta. So I have expressed the whole square in term of 1 minus cos theta into 1 minus cos theta. And here in the denominator I am getting sin square theta. And by using your identity, that is your sin square theta plus cos square theta is equal to 1. I can express sin square theta in terms of 1 minus cos square theta, which is lying in the form of what? A square minus b square. So a square minus b square again can be expressed in terms of what? A minus b into a plus b. So this I have written 1 minus cos theta into 1 minus cos theta. Denominator, then I will express this sin square theta in terms of 1 minus cos square theta. I can write the denominator in terms of what? A square minus b square. And then I expressed it 1 minus cos theta into 1 plus cos theta. So if I will cancel it out, so I will be getting 1 minus cos theta upon 1 plus cos theta, which is your right hand side. So that's all. If I start with the left hand side, definitely I will be reaching at right hand side. Now suppose you want to start with this, then there is another option available with you. If you do have the thorough knowledge of the algebra, when these are lying in these kind of binomials, I have the option available with me that I can think about rationalization, that is to write my denominator somewhere in terms of a minus b into a plus b. And you do that. Again you will be reaching here. Now you want in terms of square, so So you just expand it. 1 minus cos theta and 1 minus, this is again cos square theta, a plus b into a minus b. So then a square plus b square minus 2ab, it becomes 1 plus cos square theta minus 2 cos theta, and 1 minus cos square theta I just can express as sin square theta. Now if I will write 1, 2, 3, 3 terms are there in the numerator, 1 by 1, 1 upon sin square theta plus cos square theta upon sin square theta minus 2 cos theta into 1 sin square theta. I have split it upon sin theta into sin theta. Now let us see. Why? Because if I am focused, I need cosec and cot here. Very clearly I am getting cosec is the reciprocal of sin, cot is cos upon sin, and then cos upon sin into sin will make it cosec into cot. So then I will be able to express it in the form of a square plus b square minus 2ab, which is possible to write a minus b whole square, which is your left hand side. So this is the conditional identity. Either you start with left hand side or you start with right hand side, but just take your decision to which side you need to give the preference just in the beginning. So that's your choice. Now from the time management point of view and from the understanding point of view, you have to proceed. Now let us have a look for the second part. Prove that cos a upon 1 plus sin a plus 1 upon 1 plus sin a upon cos a is equal to 2 second. So here you see the right hand side simply is 2 upon cos a. No other possibilities there to start with this side. So better you start with the left hand side. What are you going to do there? Now you need sec, nothing in between. Either you take the LCM of both, you will be getting cos a into 1 plus sin a. Then proceed after taking the LCM, you will be getting here cos square a plus 1 plus sin a whole square. Now the another possibility to expand this is cos square a square plus b square plus 2ab. Now you are getting cos square a plus sin square a, and I know that is equal to 1. So 1 plus 1 will make it 2 plus 2 sin a. 2 plus 2 sin a, and then upon it is cos a into 1 plus sin a. So 2 plus 2 sin a, again I can take 2 common, here I will be getting into 1 plus sin a. Upon cos a it is, so again I will be getting 1 plus sin a. Now I can cancel 1 plus sin a with 1 plus sin a, and I am left with what? 2 upon cos a, which is equal to 2 secant a, so that is equal to right hand side. Means as soon as, because left hand side already is given in terms of cos and sin, so the other option left is calculations. Calculation is taking the LCM, solving using the identity wherever it is possible to write in form of a plus b whole square or a minus b whole square and their expansions. Please keep on doing that. The things automatically will be coming existing into your answer, and that knowledge of applying that identity and solving that identity is a very important part of your answer. Please keep a watch upon that. So always do practices with constant minds, and you need to concentrate at the initial stage. This is required here in these sums. So the third sum of this question number 5, third part is, now you need to prove that tangent theta upon 1 minus cot theta plus cot theta upon 1 minus tangent theta is equal to 1 plus secant theta cosecant theta. Again, now this is a question which is a kind of category in which I need to solve both the sides. That is another possibility. First you solve the left hand side, and then if you want to convert secant in terms of cos and cosec in terms of sin, so you can go ahead. The solution whatever you are getting with the left hand side, give that number 1, and the solution whatever you are getting with the right hand side, give that number 2, and then compare finally 1 and 2. So in that way also you can proceed simultaneously with left hand side as well as right hand side. But what I did, look at this, I started with left hand side. So tangent I have expressed in terms of sin theta upon cos theta, and 1 minus cot I have expressed cos upon sin. Similarly here cot I have expressed cos upon sin, and 1 minus tangent I have expressed sin upon cos. So then here sin theta upon cos theta. This is sin theta minus cos theta upon sin theta if I take the LCM here in the denominator. So here I will be getting sin theta minus cos theta. And here this is cos theta upon sin theta. If here I take the LCM, so cos theta, this will become cos theta minus sin theta. Now, from the LCM point of view, again you need to give out of box thinking here that you need to apply. What happens? See, this is sin minus cos. You can make it also sin minus cos if I take minus outside. That I did here. This I have written as it is. Here I took that minus sign outside the bracket to express this cos minus sin in terms of sin minus cos. And I did that. Then sin upon cos, this is the numerator. When you write the denominator, this will get interchanged. So it will be the reciprocal of this sin upon sin minus cos. Similarly, plus divided by minus is always minus. So cos upon sin is there in the numerator, and this you can express as cos theta upon sin theta minus cos theta. Now the next part, sin into sin square upon this into this. Then cos into cos square, then this into this. Then here it is now. Cos theta, sin theta, and sin theta minus cos theta into sin theta minus cos theta. So when I took that minus sign common, it makes my calculation more convenient. Otherwise, no issues are there. You can have this also in terms of cos into cos minus sin, but then your calculations will become very lengthy. Long brackets you have to solve, and you have to focus. You have to concentrate more upon the calculation part. So you try in that way also. The answer still you will be getting. That is possible. I am not denying for that. But by doing this, now it is comfortable. This into this, and now this is common, so I have to write only once. So that was the purpose to take minus common there. Now do the calculation. You will be getting the numerator a cube minus b cube, that is sin theta minus cos cube theta. So a cube minus b cube is what? A minus b into a square plus b square plus ab. So you have to recall that identity which you did somewhere in class 9. What is a cube minus b cube? A minus b, a square plus b square plus ab. Now a is sin theta, b is cos theta, and write the denominator as it is. So now when you have written a minus b, this is sin minus cos, this is also sin minus cos, so you can cancel it up. Sin square theta plus cos square theta, I can write 1 plus sin theta cos theta, and denominator is cos theta sin theta. So if I express this individually, so this will be 1 upon cos theta sin theta plus sin theta cos theta upon cos theta sin theta. So 1 upon cos theta sin theta can be expressed as secant theta cosecant theta, plus this will go off and you are left with 1, that is equal to your right hand side. So 1 plus secant theta cosecant theta, so secant theta cosecant theta plus 1 is the same thing. So this is very important from the understanding point of view. That's why I think within this lecture I would like to finish within 3 parts only, so that you can spend the quality time to understand this. Then by the next lecture I will be sending you the next parts. Thank you. Have a nice time.